In the 1960s, amidst the Cold War, the Soviet Union embarked on what was to be one of its most ambitious engineering feats, a pipeline that would stretch over 4,500 kilometers from the oil fields of Siberia to the industrial heart of Western Europe. The Trans-Siberian Pipeline was not just a project, it was a bold statement, a testament to Soviet engineering prowess. But despite its monumental scale and vast investment, this billion-dollar project became a colossal failure. What went wrong in building this frozen energy giant? Let's take a closer look at the saga of the Trans-Siberian Pipeline, a tale of ambition, mismanagement, and harsh realities. The vision and ambition. The Soviet Union in the 1960s was at its peak. Under Khrushchev's vision, the USSR sought to demonstrate its superiority on the global stage, not just through military might, but through technological and engineering innovation. To fuel the growing industries of Eastern Europe and maintain control over its vast territories, the USSR set out to create the Trans-Siberian Pipeline. The plan was simple: transport vast amounts of oil from the Siberian oil fields to the rest of Europe, unlocking immense economic power in the process. At the time, the pipeline's ambition was unmatched. The project was intended to span the length of Siberia, one of the coldest, most remote regions on Earth, stretching from the oil-rich regions of Western Siberia to the European industrial heartlands. For the Soviet Union, this pipeline was much more than an engineering project. It was a symbol of their global ambitions. If successful, it would secure energy supplies for Eastern Europe, diminish dependency on Western oil, and assert the USSR's dominance over global energy markets. However, what seemed like a strategic victory would soon turn into an economic and technical disaster. The harsh Siberian terrain. As the construction of the pipeline began, the engineers quickly faced the brutal realities of Siberia's environment. This was no ordinary construction site. The freezing temperatures, often dipping as low as -60 degrees Celsius, created unimaginable challenges. The frozen tundra made even basic tasks like transporting materials and laying down pipelines an enormous struggle. The workers, many of whom were inexperienced with such harsh conditions, found themselves battling not only the severe cold, but also deep snowstorms and icy winds that often delayed progress. But the real challenge wasn't just the cold, it was the permafrost. Siberia's ground, permanently frozen at many points, would shift and move as the temperatures fluctuated. This unpredictable nature of the ground made it difficult to lay the pipes properly. The design of the pipeline hadn't fully anticipated the damage that permafrost would cause, which led to an unstable foundation for the pipeline. The severe environmental conditions meant that construction work was often halted for weeks at a time, adding significant delays and costs to the already troubled project. Even with the best technology available at the time, no one could have predicted the level of disruption that the permafrost would cause. In some sections, the ground beneath the pipeline shifted so dramatically that workers had to move entire segments of the pipeline just to keep it stable. To say that construction was challenging is an understatement. It was a battle against nature itself. Corruption and mismanagement. Even with the monumental challenges posed by nature, the real rot began to set in from within. Corruption and mismanagement plagued the entire pipeline project. Bribes were common, and many contracts were awarded to firms with questionable track records. Workers were often given substandard equipment and inadequate training, which further hampered progress. Instead of focusing on quality, Soviet officials, under immense political pressure, pushed for speed. But speed meant cutting corners, an approach that proved disastrous in the long term. Subpar materials were used in the construction of the pipeline, and the quality control systems were virtually non-existent. Corruption also led to inflated costs, with much of the budget funneled into the pockets of officials rather than the project itself. This mismanagement wasn't just about wasted money, it was about the very foundation of the project being compromised. The Soviet leadership, eager to prove their power, chose speed over safety, and the result was a pipeline riddled with flaws from the start. As the project continued, more and more issues emerged. Cracks in the construction became apparent, and leaks were increasingly common. What should have been a project that represented Soviet strength became one filled with inefficiencies, missed deadlines, and growing frustration. Yet, even as problems mounted, the political pressure to finish the pipeline remained. Political pressure and deadlines. To make matters worse, political pressures mounted as the Cold War intensified. Soviet officials, desperate to showcase the project as a symbol of Soviet strength, set aggressive deadlines for completion. But construction was not progressing at the speed desired. Political pressure led to rushed construction, with workers forced to complete sections of the pipeline without proper checks. This led to structural flaws that would later manifest in cracks, leaks, and even explosions. Soviet leaders, preoccupied with political prestige, demanded results without regard for the underlying complexities of the project. Engineers and construction workers, under immense pressure, often neglected the details in favor of meeting political milestones. The consequences of this approach would soon become evident as the project faced one problem after another, from faulty welding to leaking sections of pipeline. The political need for speed had undermined the very foundations of the project. Each political milestone was viewed as an opportunity to demonstrate Soviet strength, but the costs of meeting these deadlines were significant. The Soviet Union wanted to be seen as an unstoppable force, but that same drive for speed caused them to ignore the basic principles of quality engineering and safety. The technical failures. Even when the pipeline was operational, it was far from the success that the Soviet Union had hoped for. The permafrost caused the ground to shift, cracking the pipes and causing oil leaks. In some areas, the pipes were poorly welded, leading to more leaks and ruptures. These cracks weren't just a minor issue, they represented a fundamental flaw in the project's design and construction. With harsh Siberian conditions continuing to take their toll, the maintenance of the pipeline became a never-ending struggle. Engineers were often forced to make temporary fixes, using makeshift solutions to patch up the cracks and leaks. These fixes were unsustainable, leading to further deterioration. Instead of the Trans-Siberian Pipeline being the backbone of Soviet energy, it quickly became an ongoing problem that required constant, costly repairs. The technical challenges were compounded by outdated technology and a lack of modern equipment, which were crucial for such a massive and demanding project. The engineers, already working under tight deadlines, were forced to improvise with inadequate tools, making fixes that only worked in the short term. In a way, the pipeline had become a patchwork of failed solutions. The once promising energy lifeline had become a series of leaks, cracks, and constant repairs. Financial cost and economic toll. The pipeline wasn't just a technical and logistical failure, it was also an economic disaster. Originally, the project was estimated to cost billions of rubles. However, the actual cost far exceeded expectations. The constant repairs, delays, and inefficiencies pushed the price tag into uncharted territory. And as the pipeline's failures mounted, so did the financial burden on the Soviet Union, which was already grappling with economic stagnation. While the Soviet Union had hoped to see immense returns from the pipeline, the financial reality was much grimmer. By the 1980s, the pipeline had become a financial drain, requiring constant investment just to keep it operational. Instead of bringing economic growth, the pipeline had become a costly, never-ending problem. For a country already dealing with economic issues, the Trans-Siberian Pipeline became a symbol of wasted resources and failed ambition. The collapse and legacy of the Trans-Siberian Pipeline. By the time the Soviet Union collapsed in 1991, the Trans-Siberian Pipeline was in a state of disrepair. The infrastructure was outdated, and the pipeline, which had once been hailed as a marvel of Soviet engineering, had become a decaying relic of the past. Some sections of the pipeline were abandoned, while others became neglected and inoperable. The economic cost of maintaining the pipeline far outweighed its benefits. Today, much of the pipeline remains inactive, a reminder of the colossal failure of Soviet ambition. While parts of it continue to serve modern-day Russia, the pipeline's legacy is marred by the issues it faced: corruption, mismanagement, technical failures, and a massive financial toll. What was once a symbol of Soviet power is now a cautionary tale of the dangers of overreach and poor planning. The Trans-Siberian Pipeline in its original form was a symbol of the Soviet Union's ambition, but also its hubris. A testament to the incredible human drive to overcome nature and political rivalry, it was envisioned as a project that would secure energy independence for an empire. But what it ultimately demonstrated was the disastrous consequences of unchecked ambition and poor planning. A project that sought to showcase Soviet power and technological prowess became one of the largest engineering failures in history. As we look at modern-day energy infrastructures, we can see how the lessons of the Trans-Siberian Pipeline project have shaped the way we approach engineering today. Today, pipeline systems are more advanced, with real-time monitoring, adaptive designs, and more resilient materials that can withstand the most extreme conditions. But this didn't happen overnight. The Trans-Siberian Pipeline, though a failure, contributed to the evolution of global energy systems. It exposed the vulnerabilities in design, logistics, and the devastating costs of neglecting proper maintenance. The legacy of the Trans-Siberian Pipeline is not just about the failure itself, it's also about how we as a society learn from such failures. Today's pipeline systems are designed with advanced safety protocols, including more sophisticated materials that can handle permafrost and environmental shifts, problems that doomed the Soviet project. Today, energy projects around the world take into account sustainability, regular inspection, and global climate conditions that the Soviet Union failed to address. While the pipeline's failure left an indelible mark on the USSR's reputation, it also taught the world critical lessons in engineering, management, and geopolitical responsibility. We now understand the importance of comprehensive planning, the value of long-term investments, and the necessity of maintaining infrastructures that form the backbone of entire economies. The Soviet Union's dream of energy independence turned into a cautionary tale, one that reminds us that even the most ambitious projects can falter if the details are ignored. Now, decades later, the Trans-Siberian Pipeline stands as a relic of ambition and failure, its rusting pipes telling the story of an era where mismanagement, corruption, and political pressure led to a frozen disaster. But through this story, we can see that failure is not the end. It is at times the beginning of growth and innovation. The project, while a tragic failure, sparked necessary improvements in energy and infrastructure planning, influencing the way the world designs and manages energy systems today. It was a multi-billion-dollar lesson in engineering, resilience, and the realities of working under immense political and environmental pressures. If you found this story fascinating, if you want to dive deeper into more tales of history's great engineering feats and failures, make sure to hit that subscribe button, and don't forget to click the bell icon to stay updated. Join us next time as we explore more untold stories that shaped our world. History's greatest failures are often its most important lessons.